Hey class, it's Professor Rourke again. I wanted to make just a video talking on sort of like a meta level about some of the questions in the 7.2 trig integrals Webassign. Okay, so I made a longer video going through all of the loveliness of number 12, okay, and talking about how, yes, it is like the third sister of the trig identities that we often don't see a lot, but it mostly follows the same pattern. However, 13 and 14 kind of are different, right? And I know that's the tricky part about all of these is they're all slightly different, and it's hard to know sometimes like which direction to go. But if we're just looking at 13, first of all, let's focus on 13. So 13 says evaluate the integral. Mine has a 7. Your number could be different, but I have the integral of 7x times cosine squared. So dx. And it says use a C for the constant of integration because there's no bounds, which it's like, thank God at this point, because those were a little, sometimes they can get a little tricky, a little tough. There is some funkiness going on here though, because we have a cosine squared, which is fine. Okay. We in theory can integrate cosine squared. If you remember, we had that problem in the notes from 7.2 where we have to bust out the half angle identity, where we can replace cosine squared with 1/2 times the quantity 1 plus cosine x, 2x. So I'll just write that up here just to kind of make sure we recall that typically whenever we have like sine squared or cosine squared, and maybe just sort of like by itself in the original problem without any other things at play, this is what we're probably going to need to do, is that we're going to have to use the half angle identity. Okay, which can sort of get you on the right track. So whether or not we feel completely comfortable with it or not, I'm sorry, technically it'd be like a double angle identity, but because of the 2x in there. But either way, hopefully it makes sense that if we have we had just the integral cosine squared, we could do this. Okay. It might take a little effort and some practice, but we can. However, the problem is we have a 7x there, okay? That's kind of messing up our day because we have a whole bunch of things we can do with, like, if there was like another sine x squared there or 7 sine x squared, but not just x, okay? So right away, that makes me think I see a product of two things that aren't really accounted for in my trig identities. I think I'm gonna need to go to integration by parts. Okay, so again, I'm not going to work these all the way through just because I can make another video talking about how to do that, but I think that mostly the problem right now is not knowing what to do to start. And so I'm just trying to hopefully sort of explain that process a little bit better. The 7 is irrelevant. The 7 we can just pull out to the front if we want to, right off the get-go. The problem is the x. There's an extra x here that's being multiplied by my expression that I don't know what to do with. So that's when I'm going to think integration by parts. Okay, so then integration by parts, that's a whole other thing. Like, let's say I want to try integration by parts. So where do I even begin, right? So the main idea here is that we pick a u and we pick a dv. And how do we pick the u? Well, you don't have to, but sometimes it is helpful just in the beginning to get started when we're not really feeling comfortable, is to think about like sort of the recommended order of checking for use, right? So first we check to see if there's a log expression factor. If there's a log in there that's being multiplied, that's our u. There's not one of those. The next one, if we say is for I, is for inverse trig. We do not have any inverse trig. We do have regular trig. We have cosine squared, but that actually is the last thing we would want to pick for u in our little order of hierarchy here. The next one we would want to look for is P is for polynomials, okay? And I know it doesn't really always feel like it, but X is a polynomial. It's just x to the first. So any x squared, x term, anything like that, that is typically the first thing that we're going to want to try to pick for u. And then whatever's left over is going to be our dv. Okay, so within here now, if I have an integration by parts where u equals x and dv equals cosine squared x dx, I need to integrate cosine squared x dx. And can I do that? Yes, I can. I can do that like we did on the example the other day, where we start out by replacing cosine squared dx with this bad boy. And then we can actually use like u substitution to integrate it from there. Okay, so I hope that's somewhat helpful. We then go, once we do that, again, if you need to see this more thoroughly worked out, I would be happy to help you to work one-on-one and get that practice in. But again, I just didn't want this video to be like forever long. I just wanted to kind of give you an idea of where you would want to start. The next problem that I also wanted to make sure we sort of talked about was 14. So 14 is also a doozy because this one is a little different as well. This does not have anything sine or cosine squared. It just has 5 times, again, your 5 could be a different number, sine of 8x times cosine of 5x. So that's kind of rude because first of all, there's not really like sine squared or cosine squared. They have 2 separate values in for their x's. They have one of them is 8x and one of them is 5x. If you paid attention, we actually haven't seen that yet because that does change things. We can't just assume that like whatever's on the inside of there is the same, is equivalent. So that is where we need to bust out the pretty random product identities. And those are the ones I said you do not need to memorize. Those are on our 7.2 notes. But if I asked you to use them, or if there was like a test or anything that possibly had this on here, I would just provide it for you. Okay, so the one product identity that applies here is that they usually write it like sine of big A times cosine of big B. Here, like A would be in our problem 8x and B in our problem be 5x, then we can break it down and say it's like 1/2 of sine of A plus B. Oops, make sure that looks right. Plus sine of A minus B. Okay, so that at least we can turn everything over to at least sine, right? These could be 2 separate integrals, and just both in terms of sine. Okay, so if you weren't sure about 14, I totally understand. That one is often sort of like, oh yeah, okay, I guess I could do that. And it's only really would be applicable if you have a sine and a cosine of separate expressions inside, right? So it's not just like sine of x times cosine of x. It is sine of 8x times cosine of 5x. So we would have to break out the product identity for sine times cosine of A, sine of A times cosine of B. So again, I hope that sort of helps. I didn't go through them entirely, just sort of to help you get set up. But if you get stuck along the way, I'm always more than welcome to help answer any questions. Just let me know where maybe you get stuck so I can help give you the best feedback. So I hope this is helpful. Keep me posted. I look forward to seeing you all soon. Thanks.